Alrighty, welcome to the Get Wealth Podcast. My name is Brennan Wiersma. Please be sure to like and subscribe if you haven't already. And I know a few more people have because last episode we were at 24 subscribers and now we're at 37.
That's
So
good.
slow but steady. Today I have the pleasure of sitting down with Dr. Michael Fabian. Really excited to hear what you have to say today. One of the things I love about this podcast is I've had the chance to talk to some really cool people, and I'm sure this will be nothing short of that. So, maybe just we can start off by talking a little bit about yourself and scratching the surface of some of the stuff you've done.
Okay. Yeah, I went to I graduated from high school in Houston, Texas, and I went to the Air Force Academy in Colorado. And I majored in aeronautical engineering in the propulsion track, and then I became an officer in the Air Force. I worked a number of labs within the Air Force doing research and development. So places like Wright-Patterson and Edwards Air Force Base, Ohio, or Edwards Air Force Base, California, and doing jet engines, rockets, a little bit of directed energy work. So just a big variety. Taught at the academy. Taught at the academy kind of was a stepping stone to end up here teaching at Riddle. So I did that after retirement.
So, at what age did you know you wanted to do this career, or did you kind of just fall into it?
In high school, I was good at math and physics and science, and so I kind of knew. And my dad was an engineer, and so that kind of is okay. If you're good at math, go be an engineer. You know, it's the usual thing. And I enjoy fixing things and working on things and tinkering. So.
Yeah, you've definitely had your fair share with that. Looking at what you have on the Embry Riddle website, it had quite the rap sheet of awards and schools and different projects you've worked on. So I guess what would be one of the more interesting things that you haven't, or let's say, what have you enjoyed the most doing?
I think back on my career. What happens when you go through a career is, as an engineer, when you're a young engineer, you get to do a lot more hands-on, a lot more work. You struggle on some things, but because your toolbox isn't fully built yet, but you keep working on things. And so I remember one of my early projects was we were designing a jet engine to fly Mach 2.5 on the deck. And basically, there's not really any good defense for naval ships. If you got something that can do Mach 2.5 on the deck, it just comes at them too fast for them to do anything. And it's from an engineering standpoint, there's a lot of work to figure out how to make a jet engine survive at that kind of speed on the deck. I mean, most planes do like a plane that does Mach 2.5 usually does it at 40, 50, 60,000 feet, not on the sea level. It's because the dynamic pressure is too high and the temperature is too high. But if you design it with the right parts, you can do amazing things.
So what kind of planes are capable of that? Like what's
the F-105 kind of had the maximum speed for down low, and it certainly wasn't Mach 2.5, but it was it had a very rugged structure, and it could handle the aerodynamic loads. Most airplanes can't handle that at all.
What do you trade off to be able to do that?
What's happening is it's just like if you think about what happens with the SR-71, the faster you go, the hotter the air is on the intake. And so it's hard to add fuel and add energy so that you get more oomph out the back than what you swallowed because the temp's already so high.
Yeah.
So down at sea level, the temperature's warm, and so it compounds the problem. Up at altitude, it's much colder, and so that's part of the trick is that speed of sound, because it's a function of temperature. It's much colder up there, much lower speed of sound. So
okay, yeah, that makes sense. And what point was that? What you were working on? Was that earlier on?
That was like within 2 years of being out of college, we were working on this stuff. And it's like you have to try and figure out how to cool the turbine cooling air because it's too hot to cool the turbine. So you're like using your fuel to cool the turbine cooling air to then keep the engine alive. So it's just short duration. You can't run for very long at that. But when you're going that fast, you're covering distance pretty good.
Yeah, no kidding. And what was it was for surveillance, or what kind of
it was more for we were doing the research work in case they needed to do some type of offensive system, and how do you do that? That's what we were working on. So a lot of the times the things we were working on, there's no airframe that it's going into yet because they don't have a propulsion system to do it yet, so there's no reason to design an airframe if you can't do it. So you build the piece parts that they're going to need, and then they'll go the next step. There's a Navy program called the Rattlers that is the guys at Skunk Works at Lockheed are working on it. It's along the same lines.
Okay.
So it takes many years for things to develop and the materials to come along, but that kind of project's still going on where it's high speed strike.
So how recent is that in?
Rattlers was still. I haven't kept up with it. I was still when I was still on the Air Force. I went down to Skunk Works doing a site visit, and they were working on it. So it was 2009. They were still playing with it. If you know a lot of these things, if it gets really successful, you quit hearing about it.
Oh, okay, that makes sense. Okay, so what was the progression? So you went into the Air Force, right?
Yeah, so I went into the Air Force and I spent 4 years at Wright Pat doing jet engine and turbine design, and then I went off for a master's degree at University of Washington, and then I taught at the Air Force Academy for a couple of years, and then I went for a PhD at Notre Dame, and then I went back to the Academy, and then I went to Edwards Air Force Base at the rocket site and worked on full flow cycle, which is what SpaceX is working on with the Raptor now, but we were the world's first cryogenic full flow cycle. And then I did 3 years there, and then I went to the Flight Test Center at Edwards, and I was in plans and programs, so we hosted all the organizations that were testing. So we had the Airborne Laser was there, Global Hawk was there, F-22 was being tested out, Joint Strike Fighter was inbound, new radars for the B-52, I mean, just all kinds of things. And then after that, I went to Albuquerque, Kirtland Air Force Base. My rocket experience at Edwards, they needed somebody to help with direct energy weapon safety. And it turns out gas dynamic lasers, which is what's on the 747 airborne laser, it's a rocket engine with a window in the nozzle where the laser beam comes out. And so you're using basically rocket propellants to create a laser beam, and then you can shoot that long range and take out enemy missiles. So you're using a rocket engine to kill other rockets. So it's kind of wild.
Probably the coolest thing I've ever heard. So there was a lot there.
Yeah.
All right, so first off, you would consider yourself a rocket scientist at this point.
Yeah, pretty much, yeah.
Okay,
I mean, that's my background's jet engines and rockets.
That's a pretty. When you hear rocket scientist, it's like what the jokes people make. I mean,
Yeah.
Embry Riddle has the bumper sticker.
Yeah.
You know, actually rocket scientist. Okay, so I guess breaking that apart, you went to when you were working on the rockets that you said Tesla is working on right now, the cryogenic flow.
Yeah, full flow.
So what's that?
That's basically, if you think of something like a V2, it's got a little gas generator that they generate a little bit of hot gas that spins a turbine to spin up pumps, and that's what gave the V2 enough power to carry a bomb to London. That's like the old dumb way to do it. That's the best. I mean, that's how they started.
Okay.
And then more advanced systems, you get a fancier setup where you burn some rocket propellants in a little pre-burner at a very, very high pressure, and then take that hot gas to spin a turbine to pump everything up, and then put that stuff into the main chamber and send it out the back, and that's what the space shuttle main engine does, is that one. Okay, that's just called stage combustion cycle. The next one is full flow cycle, and I kind of describe it as two jet engines with a common afterburner. And so you've got one jet engine that's taken all the oxidizer and a little bit of fuel, pumping it up through a burner. So it's like suck, squeeze, bang, blow of jet engines. So you suck in, you've got your propellants, you squash them, you put them through a pre-burner at very, very high pressure, and then you send that to the main chamber. All the oxidizers going that way, and then you do the same thing with the fuel. With all the fuel goes through a pump, a pre-burner, and then into the main chamber. And what that lets you do is you get better performance in the space shuttle main engine. You get 50 flights between overhauls and access to space, real access to space, more like Southwest Airlines access to space versus, that's and so that Elon Musk is working on that same thing. The Raptor engine is a full flow cycle. We were working on hydrogen, oxygen. He's going to use methane and oxygen because there's methane on Mars, or you can create methane from Mars. So he's trying to build the wagon train to Mars.
So that's big picture stuff.
Big
using
picture
methane
stuff. Yeah.
Whoa. Yeah, that guy's something else. He's trying to change the way we do everything.
Yeah.
Okay, so I'm trying to break this down in my head with how that works. So what are they doing? What's the main thing they're doing differently? Is it the
in order to get performance, you got to get more pressure in the
Okay.
rocket engine.
So it's
and
the
so,
pressure
so it's
there.
so it's the pressure that you're driving up, and so like the V2, they started really basic, and it's only like 300 psi in the chamber, and so now you're talking things over 3,000 psi in the chamber,
Okay.
and so that's an order of magnitude more. That's a whole lot more performance, and so Elon's working on fun stuff to do that, and so that's Spaceship One and all that.
So, from the short time that I've been paying attention to anything remotely close to that, it seems like the more recent advancements in space travel or rocket development has been privatized or been from people like Elon taking things into their own hands. Have you noticed that throughout the duration of your career?
He's doing a lot of synergy. There's a lot of when the Russian complex all fell down. There's a lot of information that came out of because the Russians had a different way of doing things, and so by taking nuggets from them plus the entrepreneurship and financial risk, most NASA's pretty risk averse. I mean, they can't afford to have any problems.
Right.
And Elon's first 3 flights all crashed.
Problems.
All crashed, but he persevered and he figured out how to make it work. And so, I mean, sticking those landings with the Falcon 9s coming back, I mean, that's a completely different paradigm than most of the other companies were even thinking about.
It's a different
I mean, I
thing.
got when I teach my class, I show the early days of Atlas V. They were buying Russian engines, and the Russian engines were so good they wanted to explosively blow off the bottom of the Atlas V rocket and parachute down the engines, catch them on a helicopter, and land them on a barge. So that was an early scheme to try and save the engines. And so so then you shift from an idea like that, of course, that never went anywhere, to Elon sticking a landing,
Yeah, just taking out the middleman.
So that's just taking out all that all that complexity of explosive bolts to shear off the bottom, parachute deploy, catch by helicopter, land on barge. I mean, all those steps are fraught with danger, and he figured out how to do it with the original vehicle.
Okay, so I'm trying not to get too ahead of myself. So you mentioned the Russian complex fell down. What is that?
Yeah, but basically, when the Soviet Union collapsed economically, there was a lot of information that then came out. They were looking for hard currencies. I mean, that's why we're buying Russian engines for a launch vehicle in the U.S. The Atlas V uses Russian engines. I mean, as an Air Force guy working on fighter engines and stuff, it's like we would never buy a fighter engine from the Russians, but.
But they had some stuff we could use.
Yeah, they had some stuff we could use, and some people thought that a launch to space was a bus ticket to space. So, if you can get it cheaper from the Russians, do it. But there's a cost to that, because you're using a foreign country for high tech stuff when you'd rather do it yourself, because domestic supply is safer.
Right, it's less of liability.
Yeah,
you could say.
and risk.
Okay, so. Would you ever go to space? Have you ever been to space?
No, I've never been to space. My dad's been to space, but I've never been to space. So
Really? He's an astronaut?
He's an astronaut. He's a retired astronaut. Yeah.
Jeez, the whole family.
Yeah.
That's pretty cool. Yeah, I don't know. I'd want to see a few trips before
Yeah.
I actually committed to the bus ticket there. But I mean, I'd probably trust Elon too, so we'll see. I don't know if I'm going to get the chip in my brain, the Neuralink. I don't know if I'm ready for that.
That's probably, I don't know how soon that's going to happen. People talk about it.
Yeah, you mean, I don't know if you saw the pigs. He tested it like a healthy pig was walking around, and he safely removed it. Oh.
Pretty
Scary.
wild.
We're
Pretty
turning
wild
into
stuff.
the cyborgs.
Yeah, pretty wild stuff.
Man, that's crazy. Okay. So you're in the Air Force. You're working on rockets at Notre Dame. And how long did you do that?
I got my PhD at Notre Dame, and then I went to Academy, and then I went to Edwards Rocket Site, and then went to Edwards Flight Test Center, and then I went to Kirtland, and then at Kirtland I made full colonel, and then I went back to Wright-Patt to be the deputy director of the propulsion directorate, and that was my swan song assignment, last assignment in the Air Force. And then when I got ready to get out, I started looking for jobs, and there was an opening here at Riddle.
All right. Going back, you mentioned you worked with directed energy
Yeah.
weapons, and you were talking about how they use that a little bit.
Yeah, so like the airborne laser program, that was the idea was you fly a 747 off the coast of Japan, pointed toward North Korea, and if North Korea ever launches something, you take it out, so everything falls back on them. So that beam can reach far enough that as the missile's coming up, you burn through the side with a laser beam and take out the tanks and the propellant tanks and all that, and then whatever nasty thing they got on top falls back on them instead of on somebody else.
Holy smokes! Most
Yeah.
people, I didn't know that exists.
Yeah, well, the project eventually got, they did all the research, the technology works. I think the cost was probably pretty high. So now they're working on solid state lasers that instead of, because it's gas dynamic laser, you have to have a rocket engine in the back of a 747 to create that beam.
Right.
And there's actually 6 of them. So gas dynamic lasers.
Smokes. Okay, so the little bit of Google searching I did, there's particle beams.
Yep, there's particle
sonic beams.
Yep. Yeah, I've been shot by the active denial system. That's one where it's an invisible beam that makes your skin feel like it's on fire.
With sound, right?
No,
Nope.
this one's 95 gigahertz. It's millimeter wave, not like a microwave oven. It's a different wavelength, but it's close to microwave oven, and it penetrates a 64th of an inch into your skin, and it makes your nerve endings feel like they're on fire. It's a crowd control weapon. It's not permanent damage. It just pushes you. You can push people around with a broom, because it's so hot they move away.
What?
And so after Black Hawk Down, with the helicopter in Mogadishu where we lost crew members and stuff, and the crowd came rushing in, they talked about putting them on C-130s. They made the one I got shot with was on a Humvee vehicle, so it's an antenna on the top of the Humvee, and they shoot it at you, and it's got some decent range.
Is it on purpose?
Yes, yeah. So,
Okay.
Yeah, so I was a test subject. Yeah.
Okay.
Yeah. So
and you were good to go afterwards?
Yeah, good to go afterwards. It's like you're in a campfire. That's what it feels like. But it's only for a little time, and then you run to move away from it. So it's just so there's different systems that are out there that people are working on.
So the first direct energy weapon, from what I looked up, is that it was Archimedes. He used it against incoming enemy ships.
Yeah,
with mirrors.
Archimedes. Archimedes with mirrors. Yeah, supposedly mirrors, and he could catch the sails on fire and all that. I think that's probably partially legend.
Okay.
But I mean, you can do amazing stuff with concentrated.
So it starts out with mirrors, and then we're 70,000 feet above North Korea shooting missiles.
Shooting missiles down.
That's insane how that just changes into one thing to another. Yeah. Okay, so what do they do with that now? Are they still using those, or how long did you work with them?
I worked on that for 2 years when I was at Kirtland, and so I was involved in the safety aspects and trying to make sure we did everything carefully and all that. People are still working on aspects of those kind of programs. When I was there, they were designing a C-130 aircraft with a littler unit that could come down through the bottom, through the belly, and it was for the special ops guys. So that when they're doing their thing, they can take infrastructure out, or like you can make a tire on some guy's car basically melt because it's an invisible beam, and so he may not even realize what's happening until and so you can change the situation remotely and not put anybody at risk, and so
that seems like magic. Like that's not a real thing, but it is.
So those guys were working on it for tactical use.
Okay, and from what we know, my mind wanders. Like, would the government, if they have something like that, be using it in any way?
Well, you got what you have to do is look back at something like the stealth fighter. When the stealth fighter, that whole thing was going on in Nevada, flying them, testing them. There were squadrons, and the U.S. didn't know anything about it until the Gulf War comes out, and then they use them. So they'll use them when they need to.
Because I imagine the average person doesn't necessarily know that's a thing. Directed energy weapon sounds like a conspiracy to me. Yeah. But obviously there's a lot of. You worked there. How long did you deal with those?
2 years.
2 years. Okay.
2 years.
And it was with the safety aspect of it.
Yeah, safety. So I worked at the Air Force Safety Center, and I was the chief of directed energy weapons safety. So I worked with the Air Force Research Lab. There's a directed energy weapons directorate, and then there's basically the Missile Defense Agency was in charge of the 747 for the airborne laser program. So there's different organizations that are testing out things or trying things out.
on you sometimes.
Yeah, well, yeah, if you're going to work the safety aspect, you got to be willing to be shot by it, because
I respect that.
because if you're gonna say it's okay, you got to prove that it's okay. And it's not a lethal weapon by any means. It's one of those things where you can lose a war by CNN, right? The CNN coverage can make it so bad you can lose a war, and so these things, shooting people with rubber bullets, and so by having something that doesn't injure them.
Is it have? I mean,
There's no lasting effects. All it does is it penetrates your skin and it vibrates your water molecules.
And that just feels uncomfortable.
It feels uncomfortable.
Yeah.
And so that's all it does. It's not going to cause cancer. It's not the right wavelength to cause it. A sunburn can cause cancer, but this thing can't cause cancer.
It seems like they would have used that already with the riots.
I think people are worried about what they don't understand, because it's an invisible beam. That suddenly you're being shot by. What are the effects? They've done all the testing.
You think that's been used?
I think they've used it a little bit in the Middle East, but there isn't much coverage of it.
Okay. Man, I hope.
They worked on some smaller versions for the pirates, the little Somali pirate boats that come out and try and hassle the ships off the African coast. They were trying to figure out how to put these things so that they could push those guys away in their little pirate boats.
Yeah, I'd rather them just do the harmful beam for those ones. Just give them the real particle beam or whatever.
Yeah, some of the guys I think they're worried about having arms on merchant ships.
Yeah. Okay.
So.
How far away is that usually?
I can't talk about that.
Oh. I mean, you mean like in the atmosphere? You can't talk about that?
Yeah.
Okay.
Yeah. It's the capabilities.
Got it.
Yeah.
That's the part that we can't know.
Yeah.
Man, that's insane. Okay, so let's work our way down the list here. So, space and propulsion. How long did you work with that?
I've worked on and off with either aircraft or rocket stuff most of my career. I mean, that's been most of my career is working on things to either be first stage, rapid turnaround stuff, whether it's runway to lift something smaller and send it to space. I mean, when I worked at the Flight Test Center, the guy that was the commander, he was earlier in his career, he'd launched a missile off an F-15 that took out a satellite in space. So you think about that. Okay.
I can't think about that. I don't know.
Yeah. So that capability existed way back when he did that.
What's the future looking like with space travel?
With space travel, I mean, the old cost was $10,000 a pound to space. So when you start figuring out what you weigh, just what you weigh makes it a dang big price tag to get there. Yeah. But they're trying to get it down to being $100 a pound or $200 a pound, so that then it becomes a reasonable number, so that you can start doing things. And I mean, obviously, there's opportunities of something like there's helium-3 on the moon in the regolith or the dirt of the moon, and you could use that for fusion power if they can figure out how to do fusion power, and that would basically give you unlimited power on Earth.
Who figures that out? I mean,
physicists figure all that out. But I mean, so when the infrastructure's there, that will happen. Okay, so you'll end up with mining on the moon to get that, and obviously people are talking. You read about things about terraforming on Mars, and I mean that's long range, but it's like there's only so much space, there's only so much resources here. People are looking for other things to do and other things to try.
So what happens when people like Elon Musk get bored?
Yeah,
they start. I'm not sure if I was reading this from what you've done or just some random thing online. Are they using directed energy weapons or any sort of space propulsion things for protecting Earth, like as far as security of the planet? I know
there's been concepts about trying to divert asteroids, but you have to detect them far enough out to give them a gentle push with a beam, and it could be you're putting a force on the asteroid to push it in a different trajectory so that it misses the Earth. And so that's long range. Now, when I was working out at the rocket lab at Edwards, we had a guy from Rensselaer Polytechnic that was working on what's called laser lightcraft, and it's a pulsed laser, and the thing rides on a laser beam and climbs. And so you can Google lightcraft, and you'll see little videos from White Sands Missile Range where the thing's going pulse, 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 and it's climbing into the sky on a pulsed laser beam. So I mean, there's ideas that are out there, and so we'll see how things develop.
I was reading somewhere that once a year we pass through what's called the Torrid meteor stream, and there's it's not as much. I mean, it's more of a concern than people think about, things colliding with the Earth. And I'm not sure where I read this, but have you ever heard of asteroid mining? Is that a thing?
Yeah, asteroid mining. Yeah, I've been teaching an advanced space propulsion class for a number of years, and I think there's now 3 companies that are working on asteroid mining. Right now they're building small satellites to have with sensors to figure out what materials are on the asteroids, which ones are worth mining. They think there's a lot of rare earth metals and valuable stuff, and so that makes economic sense. I mean, one of their concerns is if they can get the mining going on an asteroid, like if you bring too much platinum back based on supply and demand, you'll hurt the price.
Oh.
So it's kind of like the diamond market, where those guys control the diamond market. They only release so many,
That's interesting. Okay, so the future is looking like we're going to be in space more often. Is that in my lifetime, in the next
I think
decade
it's probably in your lifetime. There's a renaissance going on. If you think about what happened, I mean, in the 60s, they thought we were already going to be on the moon and have moon bases by the year 2000, and here we are 20 years after that. And so things are happening much, much faster now when you have Blue Origin and SpaceX doing all the things that they're doing. I think things are going to start happening. I mean, Bigelow Aerospace is talking about having flying their own version of a international space station. I mean, so there's companies talking about things that normally governments do that they're talking about. Obviously, it's going to be smaller scale than the International Space Station, but when you got companies talking about doing things like that, it starts to become real.
Is there any sense of competitiveness with the other countries of getting there first? Does that give us some sort of an edge?
Oh yeah, I think China's on the rise, and so just like the space race with the Russians, with China on the rise, I think that will drive things too. They're working on things. They're absolutely working on things.
Yeah, and I mean, there's probably no way of knowing what they actually are doing.
Yeah.
But it's interesting to think about leaving Earth being more of like a commercial thing, where the everyday person. I mean, maybe not. I don't know how soon that would be. Where it's like
so that's still a ways off, but competition will drive progress.
Yeah. What would you say you're most proud of in your career, of what you've done, or something you've worked on, sending a satellite to space?
It's probably working at the rocket site and working with NASA when we did it was called the Integrated Powerhead Demonstrator, and it was the world's first cryogenic full flow cycle. And when you do a world's first, that's exciting.
Yeah.
And so that was good stuff. I mean, I enjoyed the work. I enjoyed the team I worked with. We worked with Rocketdyne and Aerojet, and those are good companies that did good stuff. And so it was a lot of fun. And so I look back at that as that's when you get to do a first, that's pretty. As an engineer, that's pretty neat.
Yeah, can't pick much better than that.
It was supposed to go on a space plane, an Air Force space plane, and the space plane never got its money. So we made the engine work, but then since the space plane never got its money, we stopped. Because if you don't have an end result, give me another challenge.
Yeah, that's awesome. I don't know if you saw from, who was it? The Pentagon was releasing some weird stuff in the news about off-Earth vehicles and
Oh, the UFO stuff?
yeah, and they released
Yeah.
that clip saying that they had an unidentified object that was going from like 0 to 60,000 feet. What's that all about?
I have no idea. That's that stuff you sit there and go. I mean, the conspiracy theorists go crazy. I have no idea, what that stuff is. I wasn't plugged into that world, and so I don't know. I didn't live in the Intel world because that all goes into the Intel world. And so I don't know. I mean, I don't know what it is. Some of the things, it does defy logic. It makes you wonder what's going on. It makes you wonder, are the Chinese or the Russians up to something bizarre and they're just playing with us? I mean, I don't know. Or is it something crazy? I mean, the odds of it being extraterrestrial are pretty low. We've been listening for radio signals and all that other stuff for a long time. And they'd have to be pretty sneaky to do that. But who knows?
Yeah, it seems like the most convenient time for them to release that was just in April, where they kind of tucked it in between the fires and the pandemic and all the other crazy stuff in the news, where it was just like another headline in 2020. Oh, the aliens,
it's just
cool.
2020.
We'll save that. We'll not think about that for a little bit. I don't know. That was just the weirdest thing to me, and no one was paying attention to it. But maybe we'll figure out more later. Let's see. So, from what I remember reading in your resume or CV that Embry Riddle had, it sounded like you were in charge of a lot of things. It mentioned there was a $2 billion of facility with thousands of people.
That was my last assignment when I was deputy director at the propulsion lab, and so at that time we were working on the X-51 scramjet. That's a hydrocarbon powered scramjet. You basically drop it off a B-52, a rocket gets it up to about Mach 4, and then it shifts into scramjet mode and go out to Mach 6.
What's
and so
scramjet?
Supersonic combustion ramjet. So it's faster than an SR-71 spy plane. And so we were working on that. We were working on biofuels for the entire Air Force fleet so that they could run on a 50-50 blend of synthetic fuel and normal fossil fuel. That way, if we had to shift to something, we could. We're working on, there's turbojets, there's turbofans, and then there's 3 flow stream engines, and they really don't even have a name yet because it's so new. And so we were working on it. Turbojet only has 1 main stream. A turbofan has the fan stream and the core stream, and then the next one has 3 streams. And that lets you cut down on your infrared. It lets you get better range. It lets you get better performance. And so there's all kinds of applications for that kind of technology. So we were working on all kinds of fun things that were rockets. That group was in charge of power, ramjets, scramjets, jet engines and anything like that, and rockets. And so we were the Air Force portfolio for research and development and all that. It was 1,000 people and a pretty big budget, and it was fun job. I mean, but the trouble is you're up in leadership, you don't get your hands dirty anymore.
Okay.
So as you move up, you move away from
The stuff
turning wrenches. That happens in almost anybody's career. I mean, Elon Musk probably wishes he could turn more wrenches, but he's got company to run.
He's got a lot of things to handle, and he still finds time for Twitter.
Yeah.
So what position were you in that? Were you like the number 1?
I was number 2.
Number
I was
two?
number 2. So I was the chief, the highest military, and then there was a civilian, senior executive service civilian. That's like a general equivalent within the civilian system. And so the military is a combination. Like the Secretary of the Air Force is a civilian, and then the general, Chief of Staff of the Air Force is a general. So there's the president is a civilian. So there's it's a chain. There's a chain of command, and so I was second in charge for that organization. So we had about a $350 million annual budget doing work.
That seems like so much responsibility for, one person or maybe a couple at the top, and being able to make things run smoothly. How did that, or what did you learn from that as far as leadership or making decisions, that kind of thing?
You've got great people that are in charge of the divisions that are doing the various area, and you're keeping communication going, and you're keeping a positive attitude in the organization, and you make sure everybody's focused on the mission. And so you just and you realize anything you do is going to help the tip of the spear, the warfighter, in what they need to do. You want to keep America best so that we're never surprised and that we can always win. And that's the kind of the mindset. You don't want to be caught with your pants down, and so you just make sure you got the right things for your troops. So that's what we focused on, and so capability to put things in space that can watch what's happening, capability to bombers, fighters, transports to get everything you need anywhere in the world. Power systems. We had guys working on a really cool fuel cell system. If you think about what a special ops guy does, he's got a laser designator to help with the planes. He's got his binoculars and night ops.
Mm-hmm.
He's got his radios. He's got all this different stuff, and every battery is different for every single one of them. And then you don't know how good the batteries are, how much life is left in them. So the dude has to carry all these spare batteries for all that stuff so that he can coordinate the fight when he's in the middle of stinking nowhere. And he's offloading ammo in order to carry batteries because the batteries bring in friendlies to save him. And so and so basically we were making this fuel cell system so that you could just patch cords up so that the laser designator or the radio could just connect to the fuel cell. And the beauty of like a methanol fuel cell is if you got a quart bottle of methanol, you know how much fuel you got. In a battery, you kind of go, maybe it's 50%. You run into that with your phone. I mean, you kind of know, but you wish it had more.
Yeah.
So just lots of things like that where we were trying to help.
Yeah, that's, helping in a big way.
Yeah.
As far as in the big picture of what, what you're leaving in the world is you're making it better than where you left it, which has got to be a great feeling. Has there been a time where you've had a setback and had to get around it, or has things been pretty smooth sailing?
Overall, pretty smooth sailing. You try and foresee things and do your legwork early so that you don't get surprised. And so I think I've been pretty lucky in my career so far, getting things done and not running into major turmoil.
That's good. When did you decide to transition to teaching and kind of passing that on?
When I got done with the Air Force, I thought, I thought this would be a neat place to retire, and I thought, teaching would be a good transition to that, and so, and being able to give back to the students that are going to be the next generation of engineers, and Riddle has a good reputation for aerospace and mechanical engineering, so I thought, okay, I can come here and help do that. And so I taught at the academy for a few years while I was in the service. And there you don't have to have a PhD to teach. You just have to have worked in that area. So they're very much focused on application of the theory. So as long as you had a master's degree and had worked in the area, they'll let you teach at the Air Force Academy. And so that's and a lot of schools it's PhD only. And so Riddle has industry folks with a master's degree that teach in the engineering department, and that they have a different view than somebody that's pure academia, and so it helps the students know a lot more.
How would you say Riddle stacks up in the big picture of engineering schools?
They do very well because of the hands-on and the clubs and all the things that are going on. And the COVID hadn't helped any, but it's a good school for theory plus application. I've seen a lot of other schools where it's all theory and the kid doesn't know anything.
They're not turning the wrenches as much.
They don't know how to turn the wrenches. And that's part of being a better engineer is knowing enough to take something apart, put it back together. How can I make it better?
Mm-hmm.
That's part of it.
And I imagine that gets pretty complicated.
Real fast.
A lot of the stuff you say kind of goes over my head. I try to understand it, so you got to immerse yourself. It's like learning a new language. That kind of goes for aviation also.
Yep, same thing.
I guess I never actually said how I got to do this interview. Typically, I do the door knocking, which this is another door knocking episode. I just picked a really beautiful home, by the way, and it happened to be a professor here, so that worked out pretty good. You think you're going to stay in Prescott?
I like the town. Yes, I think so.
Yeah, for sure, a place to retire. This is not bad.
Yeah.
You kind of got everything, the seasons and.
Right. It's not too hot in the summer, not too cold in the winter, so I like it.
What do you like to do for fun? Are you an outdoors guy? Or?
I like camping and backpacking. My sons are all mountain bikers.
Okay.
So a lot of mountain biking. I'm not the big mountain biker.
Okay.
Hiking and camping's more my style.
Yeah.
My pace.
Yeah, there's some good spots around here. Where do you stay in Prescott area? Or?
Yeah, generally Prescott area. Yeah.
Okay.
Yeah.
Yeah, I know. I've been on Senator Highway.
Yeah, Senator Highway. Yep.
Some good places up there.
Yep.
And then just off-roading and stuff.
I've done a few ventures into the Grand Canyon and stuff like that. That's always fun.
I've been there. That's one thing I really want to do. I mean, have a soup by?
I've done Havasupai. That's awesome. The trouble is it's so popular. It's hard to get tickets.
Yeah, you got to book it like a decade in advance.
Yeah, it's
to
crazy.
get a spot.
Yeah.
That's cool. All right, kind of focusing it more towards what I mean, not always, but I try to angle the podcast towards wealth, just as far as whatever way you define that. So I guess we can start with, how do you define wealth? Is that monetary for you? Is it about who you surround yourself with, or achievements?
That's when I read that question, it's a hard one to answer,
Yeah.
because I think it's not fearing for money, and it's not worrying about day to day. I think about people that struggle from paycheck to paycheck and all that. That's not wealth, and having enough to keep your family comfortable and having a plan for the future. And so I think back to little things that people told me about early on. That if a company has a retirement plan, you better be in it. And I know, like my wife's brothers, they don't even bother with the 401ks. And it's like, you put in $1 and the company puts in $1 for you. You just doubled your money, and all you had to do was put the dollar in.
Yeah,
and they don't do it. And so
free money.
I sit there and go, man, are you crazy? Matching money is free money. And so I look at that, and so anything in that realm is just, you got to be foolish to not do that.
Yeah, I mean, there's few things that are as as free as that. I mean, you're getting free money. There's tax advantage accounts.
Right.
The 401k, if your company has the match with that,
Yeah.
I mean,
Yeah,
if you can, I don't know why you wouldn't do
yeah.
it. I mean,
There's people that don't. I don't know if they don't understand it. I don't know if they don't realize. I mean, yeah, you may have to scrimp a little bit, but it isn't much of a scrimp when you look at it. That down the road, it's money in the bank.
yeah, it's gonna same thing with like if you can qualify for something like a Roth IRA.
Yeah.
I'm
Yeah.
mad I learned about it when I'm 22. I wish I would have started earlier.
Yeah, because
that's
time is the whole key to this.
the compound.
The compounding the interest
that's
and
where the
compounding
magic-
the savings. Yeah, that's the key.
What if any? I mean, it sounds like you have with investments in with the 401k or the stock market and
Yeah.
that kind of thing. What sort of investments have you made?
During the .com boom, I played the market. When my wife and I played the market, and I mean, we had some winners and we had some losers, and I mean, that's the nature of that game. And I eventually felt like the guys that are the insiders in New York always get the tip first, and so I was like, man, I don't know. So I tend to do like the S&P 500 fund. I choose funds that are just tracking certain markets.
Yeah, you
and
can't really go
that
wrong
way
there.
it's mindless. I don't need to chase it. I don't need to worry about it day to day, and I'm letting the slope of the curve over the decades on average win.
Yeah, I mean, I think it's, what is it, over a 20-year period? It's never not shown like a 10% return or something like that.
Yeah, so that's the
key.
That's the key.
Buying and holding.
Yeah.
As far as real estate goes,
I've been lucky in real estate. Real estate's one that I don't mind. I'll tell you like, we've bought nice houses. I've never owned a new car in my life. I only buy used cars. I let somebody else take the depreciation, and I find quality used cars, and I maintain them myself. And
yeah,
and
as
so
soon as
that's-
you drive it off the lot, that's
yeah. As soon as you drive it off the lot, you lost a bunch, and so that's just. But houses, because of the way the tax laws are written, you can get, I think it's like $250,000 increase in house, and they don't tax you at all on it. And so it's like that tax law is written for the wealthy people that are that are in Congress. And so it's like you play the game that benefits you try to ride their coattails. And so living in a nice house and making a profit on a house is one of those deals that's good. I mean, the trick is save that stinking first 20% so you don't have to pay the mortgage insurance, because the mortgage insurance isn't there to protect you; it's to protect the bank. So you're paying. It's like having somebody else pay your car insurance. Nobody does that. So it's the deal of the century. But once you get 20% down, you don't have to pay mortgage insurance, and that's huge savings.
Yeah, I'm kidding. That's something.
So there's just little things that make it better.
Yeah, there's so many. I mean, just diving into it and trying to immerse yourself in it, you can find so much little tax breaks and deals in there that you would have never known about, like with the real estate thing where you can
Yeah.
invest the profits and have it tax free, and
Yeah.
you know, there's certain things that are benefited.
That's a huge benefit. It's just a huge benefit.
Cool. Let's see what we got here. If you had $1,000, or I mean,
Yeah.
what would you invest for $1,000 right now? If say someone has $1,000, what would you tell them to invest it in?
I'd probably tell them just get in a mutual fund. If they're really young, get in some kind of aggressive mutual fund, whether it's in the tech area or whatever. Just jump in with one of those, because that's you just want to get in and let time. Like, I mean, way back it was the overseas markets are going to go gangbusters, and yeah, sometimes they do, sometimes they don't. And so I look at certain things. I way back when I was at the propulsion lab, General Electric was a cornerstone of America, and now they've managed to mismanage themselves down to where they're not even part of the S&P 500 anymore. They knocked themselves out. So to me, if you try to choose the horse winner with a single stock, you might get lucky, but you might not. And so I'd rather choose something with diversify a little bit and let it climb with time.
I think that's good advice, because the average Joe is not going to be able to time the market. I think, 90% of people can't time the market or are unsuccessful trying to.
Yeah. So it's just you have to be too involved and too in the know, and you just don't have the time for that. I mean, I guess if you're a stockbroker, you got the time, but that's your business.
Yeah.
But for the average person, no.
Looking back, what's advice that you would give to your 20-year-old self? If you could, would you say?
Don't live above your means. I mean, I think about, having roommates to save on rent, having a used car to save there. I mean, there's things that let me then do vacations and things so that I could do fun things. Because obviously you can't be an absolute penny pincher. Life isn't worth living. So
there's a balance.
Yeah, there's a balance, and finding the right balance for you is part of it. And so, thinking back, one of your other questions was the book. And to me, there's one out there called The Millionaire Next Door, and it's written by two guys that basically track various folks. And if you think about a doctor, everybody thinks a doctor is at the top of the thing, but he's got the medical bills, the medical insurance, everything. He's getting eaten alive by all the costs. And so it's like you can. And he has to keep up his images by having the latest Mercedes or latest BMW and all the rest. And so he's not a rich guy at all. He's got status as a doctor, but he's not a rich guy. It's the outflow. The outflow is just huge. And so they basically talk through what does it take to be the millionaire next door, and it really doesn't take that much. It's just thinking about things in the long term. Like housing investment is a good investment. And stock market investment is a good investment. A gold watch is not a good investment.
Right. Yeah, it seems like where that kind of gets into is the people, you think of the people who have the highest income as the wealthiest people, but the doctors, the lawyers, I mean, one day maybe the pilot, they're being taxed off that income. So it's not necessarily those people that are, the millionaires. It's the people that have the investments. Right. From what I've seen or the little that I've been trying.
Some of they're not flashy people.
Right.
You would never know it. That's kind of the point of the book was you would never even know it.
Yeah.
It's because the stereotypes are telling you one thing and the reality is something else. So it was an interesting book. It changed my perspective on things. Because you're keeping up with the Joneses.
Yeah. I'm for sure reading that book. I'm going to try to read all these. I'm trying to get as many as I can from people.
Right.
And that definitely sounds like a good one. The Millionaire Next Door. Alrighty, what are I guess to kind of slowly wrap things up, what are some future investments, plans, retiring?
I mean,
How's that looking?
I got one kid in college that's a senior. I got another one that's a freshman, and I got another one that's a junior in high school. So at this point, the fun things have to come after
Yeah.
helping them get through college. And so long-term plans is get them through college, and then I'll figure out, what am I going to do in terms of travel and true retirement. Right now I'm working to pay the bills and investments to help cover their college costs, and so I'm still on the grind,
I bet. I mean,
Anyway, I'm still at a decent place in life. I mean, it's
course.
okay to have a military retirement and then have a college salary and then take it from there.
yeah, no kidding. Cool. Well, I think I don't want to take too much of your time. I really appreciate you sitting down and talking. I
Brendan,
feel
no
like
problem. Thanks for having me.
I really learned a lot and learned some things about space and what I thought wasn't real yet. So, yeah, really appreciate your time.
Absolutely.